Good morning, all of you. Welcome to Sri Jayendra Rank Zone. So far, we have completed some questions regarding chemical equilibrium. Now we are discussing chemical equilibrium chapter. In that, we have done already relation between Kp and Kc and what is equilibrium constant, how to find equilibrium constant with respect to equations. Now we are going to do important questions based on that same topic. Afterwards, we'll go for new topic. As these questions are very selective, so that's why I'm writing it. Because we have collected these questions from so many, as we thought it is very important. That's why we have taken these questions into consideration. So please follow. So this is nothing but the topic is important models. Important models. Important MCQs based on chemical equilibrium. That is chemical equilibrium. That is based on Kc, Kp, etc. So all these models, if you cover, definitely you'll get this type of models in the examinations, in the entrance exam. That's why I want to discuss this. So let us now question number 1. Based on this, very simple to and toughest questions will go. So for the reaction, CO plus half O2 gives rise to reversible reaction CO to gas. Kp by Kc is equal to how much? Kp by Kc. So far we have not done this type of model. That's why I want to discuss. So Kp by Kc is equal to how much? So option A, they are given RT. Option B, RT to the power minus 1. Option C, RT to the power minus 1 by 2. Option D, RT to the power 1 by 2. Now, we already know that Kp is equal to Kc RT whole to the power of delta n. I'm writing the solution. So please note down. Kp is equal to Kc RT whole to the power of delta n. Now, by this we can say Kp by Kc is equal to RT whole to the power of delta n. So if you find delta n value, now implies delta n is equal to what? Number of moles of products minus number of moles of gaseous reactants, only gaseous reactants and gaseous products. So here, number of moles of gaseous products. What is the product here? Carbon dioxide is a gas, so we can take 1 mole, so 1 minus, and number of moles of gaseous reactants. We have 2 reactants, that is 1 CO as well as O2, and this should be 1.5, so we can take it as 1.5, or 1 minus 1.5, it is equal to 0.5 minus 0.5, also equal to minus 1 by 2. 0.5 can also be taken as minus 1 by 2. So it is nothing but therefore Kp by Kc is equal to just wait. Therefore Kp by Kc is equal to RT whole to the power of minus 1 by 2. So answer is this. Because we got delta n value is equal to minus 1 by 2, delta n Kp is by Kc is equal to RT whole to the power of delta n. So delta n is equal to minus 1 by 2. So answer is third option. That is C. Next, question number 2. So all these questions you can see in the screen. Next, we have question number 2. Question number 2. Please note down. For the reaction equilibrium, for the reaction equilibrium N2O4 changes to so N2O4 is given as gas, gives rise to 2NO2. It is also a gas. The concentration of N2O4, the concentration of N2O4 and NO2 at equilibrium are 4.8 in 10 to the power of minus 2 and 1.2 into 10 to the power of minus 2, 1.2 into 10 to the power of minus 2 moles per liter respectively. Moles per liter respectively. The value of Kc for the reaction is the value of Kc for the reaction is, since we are discussing all the important moles, so we have to write it because it is selective questions. You will not get from any single book. So that's why. So option 1, that is 3 into 10 to the power of minus 1 moles per liter, 3 into 10 to the power of minus 1 moles per liter. Option 2, it is 3 into 10 to the power of minus 3 moles per liter. Option C, it is 3 into 10 to the power of 3 moles per liter. And option D, it is 3.3 into 10 to the power of 2 moles per liter. 3.2 into 10 to the power of 2 moles per liter. So this is the question. So please copy it on the question. Now we'll take solution for this. Solution. So they are given equilibrium concentrations directly. So the concentration of N2O4 and NO2 at equilibrium are 4.8 in 10 to the power of minus 2, that is for N2O4, and 1.10 to the power of minus 2, that is for NO2. So for this reaction, Kc is equal to how much? Kc is equal to concentration of NO2 whole square by concentration, equilibrium concentration of NO2 whole square by equilibrium concentration of N2O4, because it is only 1 mole. So it is equal to 1 point, because equilibrium concentration of NO2 is given 1.10 to the power of minus 2 whole square by what is the concentration of N2O4 is 4.8 in 10 to the power of minus 2. 4.8 in 10 to the power of minus 2. So if you cancel out this, you'll get the answer. So you can do the simplification. So answer for this question is second option is equal to 3 into 10 to the power of minus 3 moles per liter. It should come as 3 into 10 to the power of minus 3 moles per liter. So this cancellation, you can do it. So answer is second option. That is B. So they have given the equilibrium concentration. Very important is the equilibrium concentration of N2O4 and NO2. So no need to take anything. Directly you can take the values and substitute the value. You will get the answer correctly. So this is model number 2. Next, model number 3. So all are different models we are trying. So please note it down. These are the best models we have seen so far. Next, question number 3. What is the equilibrium expression? What is the equilibrium expression for the reaction what is the equilibrium expression for the reaction P4 plus 5O2 gives rise to, and P4 is solid phosphorus and oxygen is gas, gives us to P4O10, that is also solid. Now, what is the equilibrium expression for the reaction P4O2? This one. So for this, they have given 4 options. Option A, Kc is equal to concentration of P4O10 by concentration of P4 into concentration of O2, O to the power of 5. Second option, Kc is equal to 1 by concentration of O2, O to the power of 5. Third option, Kc is equal to concentration of O2 to the power of 5. And fourth option, Kc is equal to concentration of P4O10 by 5 into concentration of P4 into concentration of O2. So these are options. These are the options for this question. Now, since already we know solution I'm doing here, so simply you can see here, for the formula for finding equilibrium constant is equal to, the formula for finding equilibrium constant is equal to concentration of products raised to the stoichiometric, raised to the power of the stoichiometric coefficients by concentration of reactants raised to the power of the stoichiometric coefficients. So this is the formula for finding Kc, because Kc is equal to Kf by Kb. Kc is equal to Kf by Kb. So since this is the formula, but here very important point to be noted down, that is the concentrations of solids, the concentration of solids and pure liquids like water are taken as unity. So since they have taken as unity, so only the thing we have, only gas is oxygen gas, that is on the reactant side. So reactant should come in the denominator, and the stoichiometric power for oxygen is total 5. So stoichiometric coefficient is 5 moles. So answer is Kc is equal to, so by this you can say Kc is equal, because the product is solid and the reactant phosphorus and phosphorus pentoxide is also solid. So answer is only Kc is equal to 1 by concentration of oxygen whole to the power of 5. 1 by concentration of oxygen whole to the power of 5. Answer is second option. So this is a question. This type of model is very important for NEET and JEE mains. So please concentrate. Next, question number 4. Model number 4. So all the important models I'm doing. So if you listen this class carefully and try to understand the numericals, definitely you can score good marks. Definitely you can answer these questions in the competitive exam. Next question. The equilibrium constant, apart from the previous questions, we are doing different models. So the equilibrium constant, question number 4, the equilibrium constant for the reaction N2 plus O2 gives rise to N2 gas plus O2 gas. N2 is gas, O2. The physical nature of reactants and products is important. Gives rise to 2NO gas at temperature T. At temperature T is 4 into 10 to the power of minus 4. 4 into 10 to the power of minus 4 moles per, nothing they have given, no unit. The value of Kc for the reaction. Based on this, the value of Kc for the reaction the value of Kc for the reaction, comma, NO gives rise to half N2 plus half O2. All are gases. At the same temperature is at the same temperature. At the same temperature is the same temperature is option 1, first option, 2.5 in 10 to the power of 2. Option B, 0.02. Option C, 4 into 10 to the power of minus 4. Option D is equal to 50. So let us take the solution for this. So in this question, they have given the equilibrium constant for this reaction is 4 into 10 to the power of minus 4. Now they are based on this Kc value. They are asking us to find Kc value for the reversible reaction with half number of moles at the same temperature. So by this you can say Kc1 is equal to, so Kc is equal to 1 by root Kc, because we need to find this, because it is reversible and it is half, so we can say 1 by root Kc. So by this you can say implies 4 into 10 to the power of minus 4 is equal to 1 by root Kc. So for the reaction, second reaction, just I'm rubbing it now again, just see here please. So we have to do comparison for the first equation and then we have to go for second equation. So second equation is reverse of first equation, and moreover it is half moles. It is, you can see here 2 moles of nitrogen or nitrogen oxide, and here 1 mole, and here 1 mole of nitrogen, half mole, and 1 mole of oxygen, half mole of oxygen. So due to this, what happens, we can say Kc is equal to 1 by root Kc1. That is the first equation. Let us take the Kc1 is equal to this. So we can say 1 by root of 4 into 10 to the power of minus 4. So root 4 value is how much it is, already we know. Root 4 value is 2. So 10 to the power of minus 4 root is 10 to the power of minus 2. So 1 by 2 into 10 to the power of minus 2. So 10 to the power of minus 2 going to numerator, it becomes 10 to the power of 2. So it becomes 10 to the power of 2 by 2. That is 100 by 2, which is equal to 50. So answer is how much? 50. Fourth option. Very, very important question. So answer is 50. So in this way, you have to find, this is model number 4. I hope it is clear. So Kc is equal to 1 by root Kc1. The one which you have to find Kc is in the, when compared to first equation, it is 1 by root of Kc1. So it is nothing but 1 by root of 4 into 10 to the power of minus 4, because this value is given. That is 1 by 2 in 10 to the power of minus 2. 10 to the power of minus 2 going to numerator, it becomes 10 to the power of 2. So 10 to the power of 2 by 2, that is 10 to the power of 2 is 100. 100 by 2 is equal to 50. So answer is 50. Next question. Question number 5. So this is model number 5. Model number 5 we are going to do. This is also very, very important. Model number 5. All the models are important. Kc for the reaction. If you can do all these models, 100% you can able to score marks in the competitive exam, entrance exam, because from this chapter, this area is most important. Kc for the reaction. Kc for the reaction at 184 degrees C. They have given the temperature also, comma. The reaction is 2NO2 plus, 2NO2 gives rise to 2NO plus O2. 2NO plus O2 is 1.8 in 10 to the power of minus 6 given r is equal to 0.083 units. I'm not writing. When Kp and Kc are compared, when Kp and Kc are compared, see the question is different here. When Kc and Kp and Kc are compared at 184 degrees C, at 184 degrees C, it is found that option 1, Kp is greater than Kc. Option 2, it is option B, Kp is less than Kc. Option C, Kp is equal to Kc. The temperature. And option 4, this is totally concept-based question. Whether Kp is greater than comma less than comma less than or equal to Kc or equal to Kc depends upon the total gas pressure. Depends upon the total gas pressure. So this is the question. Now we are doing solution for this. So for this, they are given wantedly values. Kp, Kc value for this reaction is 1.8 10 to the power of minus 6. When Kp and Kc are compared at 184 degrees C, it is found that first option Kp is greater than Kc, second option Kp is less than Kc, third option Kp is equal to Kc, and fourth option whether Kp is greater than, less than, or equal to Kc depends upon the total gas pressure. So these are the 4 different options they are given. Now, since we already know for the relation between Kp and Kc, we know if delta n, we have to find delta n. If delta n is equal to 0, Kp is equal to Kc. Again, I'm writing the conditions. If delta n is negative, implies Kp is less than Kc. If delta n is positive, then we can say Kp is greater than Kc. So if you find delta n, and how to find delta n? Delta n is equal to number of moles of gaseous products minus number of moles of gaseous reactants. So gaseous is very, very important. So for this equation, we have to find delta n. So delta n is equal to 2 plus 1. This is products is 2 plus 1 minus reactants is 2. So 2 plus 1 minus 2 is how much? It is 3 minus 2, it is equal to 1. Since delta n is positive, so therefore Kp is equal to, Kp is equal to, since delta n is equal to positive, Kp is greater than Kc. Straight away we can say Kp is greater than Kc. So simply for confusion, they are given the values. So whenever they are given the values, see the concept properly. That's why I want to discuss this question. It's very important. Simply they are given the values and temperature, and R value also they are given, so that to divert the mind of the student. But we need to concentrate only on the concept. Simply they are asking when Kp and Kc are compared at 184 degrees C, it is found that. So the option is Kp is greater than Kc. Kp is greater than Kc. So answer is first option, that is A. So like these questions are very important. So please note it down. This is question number 5, that is model number 5. Next, model number 6. Model number 6. The equilibrium constant. This model is also very important. The equilibrium constants. The equilibrium constants constants Kp1, Kp2, Kp1 and Kp2. They have given with respect to gases. For the reactions, for the reactions, X gives rise to 2y and Z gives rise to P plus Q respectively. Since they are given Kp1 and Kp2, so definitely all these reactants and products are gases only. So we need to get anything respectively are in the ratio of 1:9. 1:9. If the degree of dissociation of X, if the degree of dissociation, the degree of dissociation of X and Z, of X and Z be equal, then the ratio of total pressure, here very important concept, total pressure. Till now we have not heard this type of questions. Total pressure at these equilibria is, is option A is 1:36, option B it is 1:1, option C it is 1:3, and option D it is 1:9. So which is the right option we have checked. So listen carefully, this question is very, very important and you should know the correct answer for this. So first, let us take solution. So what they are given, Kp1, Kp2 are in the ratios of 1:9. If the degree of dissociation of X and Z be equal, X and Z are equal, then the ratio of total pressure at these equilibria is. So let us take first reaction. X gives rise to 2y. Initially it is 1 mole, it is 0. At equilibrium, we can say the degree of dissociation with respect to degree of dissociation. 1 minus x, it is 2x. 1 minus x and 2x. So for this reaction, total number of moles is equal to total, because we know Kp is equal to partial pressure of y to the power 2 by partial pressure of x for this reaction. And to find partial pressure, we know since partial pressure is equal to total pressure, that is P into mole fraction. So we need to take mole fraction here, very, very important concept. So total number of moles by number of moles. So mole fraction. So total number of moles. So partial pressure into total number of moles. So we can take it as, so Kp is equal to, for this reaction I'm writing, first partial pressure of X will take. So Px is equal to total pressure P into mole fraction. So implies total number of moles is equal to, which is 1 minus x plus 2x, 1 minus x plus 2x, because you have to add all these things. So it is equal to 1 plus x. So partial pressure of P into mole fraction of x is 1 minus x by 1 plus x, because number of moles of, how to find mole fraction of x, number of moles of x by total number of moles. Total number of moles is equal to 1 plus x. So by this you can say Px is equal to P into this Kp value, implies Kp is equal to, for this reaction Kp is equal to how much? Kp reaction. So first we have to write partial pressure of X and partial pressure of Y. Then we can go for Kp. So straight away we can't go for Kp. So this is partial pressure of X. Similarly, we'll find partial pressure of Y, because for this Kp we need to find partial pressure of X as well as partial pressure of Y. So now I'm taking to this partial pressure of Y is equal to, partial pressure of Y is equal to sorry, this capital Y you have to write. Partial pressure of Y is equal to total pressure into mole fraction of Y, that is mole fraction of Y, So it is equal to, mole fraction of Y is equal to 2x by 1 plus x. So total pressure is equal to, into mole fraction is 2x by 1 plus x, because number of moles of Y is equal to 2x and total number of moles is 1 plus x. So this is partial pressure. So by this you can say Kp is equal to P power Y square by P power x. So that is partial pressure of x, that is equal to 2x by 1 plus x whole square divided by 1 minus x by 1 plus x. This is Kp value for the first equation. Similarly, we can find Kp value for second equation. Kp2, this is Kp1 value. So Kp2 is equal to partial pressure of partial pressure of P into partial pressure of Q by partial pressure of Z. So we can write here PdK so that you can understand easily. Partial pressure of Z. So this also we can write it as for second equation. So we need to find individually all these things. For the second equation, what is second equation? Z gives rise to P plus Q. Z gives rise to P plus Q. So initially it is 1 mole, this is 0, this is 0. At equilibrium, we can say, 1 minus x is equal to x and x. So total number of moles is equal to, total number of moles is equal to 1 minus x plus x plus x. So it is equal to 1 plus x. 1 plus x. So continuation for this solution again I'm doing here. So by this you can say partial pressure of Z is equal to total pressure into 1 minus x by 1 plus x. Similarly, partial pressure of P is equal to total pressure into x by 1 plus x, because number of moles of x is this much. And partial pressure of Q is equal to total pressure into x by 1 plus x. So now this is the value. So by this you can say Kp2 is equal to x by 1 plus x whole square, that is x by 1 plus x, that is partial pressure of into P of partial pressure of P into x by 1 plus x into P is equal divided by partial pressure of Z, it is equal to P into 1 minus x by 1 plus x. So now we know the value of Kp1 and Kp2. By this you can say Kp1, Kp2 is equal to, by this you can say Kp2 is equal to, so relation between Kp2 and Kp1 I'm writing here straight away. You can just compare it. So this is Kp2 and that is Kp1. So Kp1 and Kp2 is equal to, now we can say straight away 4 into P1 by P2 is very lengthy problem, is equal to 1 by 9, because Kp1 by Kp2 is equal to 1 by 9. So 4 into P1 by P2 is equal to 1 by 9. We can say total pressure values P1 by P2 is equal to, that is total pressure P1. We can say here P1, P2. So here it's a P2, P2 we can write for this. And for the previous case we can write P1, P1. You can see here, for this case we can write total pressure, that is P1 into 2x by 1 minus x square. So Py square. So here also we can write P1 and here also we can take P1. So now we can easily consider now. So P1 by P2 is equal to 1 by 36. Answer is 1 by 36. You can cancel out that. So please do it properly. So answer is first option. That is 1 is to 36. P1 by P2. They are given the ratios of KP1 and KP2. From that we need to find ratio of total pressures. So how we got this 4, I'll tell you now. This 2x by 1 plus x whole square. So 1 by 1 plus x whole square. So 2 square is 4. So this and this gets cancelled same. And here also we have this and this because we have x into 1 by x, so x into 1 by x, 1 minus x by 1 plus x. So denominator is same. That's why you can say 4 into P1 by P2. 4 into P1 by P2 is equal to 1 by 9 because KP1 by KP2 is equal to KP1 is equal to 4 into P1 by P2, that is equal to 1 by 9. So how we got 4? I hope you understood. So this is 4 into P1 by P2 is equal to. So if you simplify KP1 and KP2 100%, you'll get the answer. And 1 by 9. So this relation you get. Once you get this relation, you can do this answer. Next question number 8. Question number 7. So model number 7 now. So this model is quite important. So that's why I have discussed with you. Next question number 7. For the following reactions, A, comma B and C, equilibrium constants are given as equation A, first equation, CO plus H2O gives rise to CO2 plus H2. And this is K1. Equilibrium constant for this reaction is K1. Equation B, CH4 plus H2O. All are gases here also. Water is gas. They are given water vapor, gas and gas. Second, CH4 plus H2O gas gives rise to CO plus 3H2. CO plus 3H2. Here also this is gas and this is also gas. It is taken as K2. Next, third equation, CH4 plus 2H2O gives rise to CO plus 4H2. All are gases. And this is K3. Now, which of the following relations is correct? Which of the following relations is correct? This is a question. So they are given three equations with K1, K2, and K3. Now they are asking relation between these three. So option A, that is first option I write here because already we have used A. So first option, K1 root K2 is equal to K3. Second option, K2 K3 is equal to K1. K2 into K3 is equal to K1. Third option, K3 is equal to K1 into K2. K3 is equal to K1 into K2. Fourth option, K3 into K2 cube. K2 cube is equal to K1 square. So this is very typical question, lengthy question. So please try to understand. It's very important question. From this you can say, carefully observe, this is K1. K1 is the product is what? CO plus H2. So K1 the product is CO plus H2. It is not CO2. So it is CO plus H2. So in all the equations product is same. So CO plus H2 and CO plus 3H2. So we can say by combining these two equations, we can see CO plus H2O and CH4 plus H2O. Whereas here CH4 plus 2H2O and CO plus 4H2. So 4H2. So this is CO plus H2O. So if you see this carefully, if you come carefully, if you observe this carefully, if you observe this, you can say solution. Here itself I'm writing here the hint. Equation C. Equation C is equal to equation A plus equation B. We can write equation A and equation B. If you take equation A and equation B, if you add these two, you will get equation C. You get what? Equation C. So that's why. So H2O plus H2O, 2H2O. CH4, CH4. CO plus CO, 2CO. So here one CO will get cancelled because this CO and this CO will be there. And because 1, 2, 3 COs are there. So 1 minus 1, you will get only 1 CO. And here H2 and 3H2, 3 plus 1, 4. So straight away, if we take equation A plus equation B gives us to equation C, implies K3 is equal to K1 into K2. Because we should not add this, so answer is K1 into K2. So K3 is equal to K1 into K2. Option is third option. So like these questions are very important. So please compare it properly. So if you add these two, first equation plus second equation, if you add those, this is equation A and equation B. If you add, simply you can get CO plus H2O plus CH4 plus reactants you add, products you add. So straight away you will get one CO will go this side, means minus CO. So plus CO minus CO gets cancelled. So remaining only one CO will be there. CH4 and H2O plus H2O, 2H2O, CH4 1, 2H2O, and CO 1, and H2 plus 3H2, it is equal to 4H2. So straight away we can say equation C is equal to equation A plus equation B. So answer is K3 is equal to K1 into K2. So like these questions are very, very important. So please note it down. Now question number 8. Question number 8 or 7 might be, whatever it is. So question number 8. So these are the difficult questions. Now we'll do some more difficult questions for this. Question number 8. The equilibrium constant. The equilibrium constant. The equilibrium constant Kp for the reaction. The equilibrium constant Kp for the reaction, comma, A gives rise to 2B. A gives rise to 2B. Is related to degree of dissociation alpha. Degree of dissociation alpha. Degree of dissociation alpha of A and total pressure P. And total pressure P. Total pressure P as option 1. So we need to find Kp. Option 1, it is 4 alpha square P, that is total pressure, by 1 minus alpha. Option 2, 4 alpha square P square by 1 minus alpha. This is quadratic equation derivation, 1 minus alpha square. Option 3, 4 alpha square P square by 1 minus alpha. 4 alpha square P square by 1 minus alpha. And option 4, 4 alpha square P by 1 minus alpha. So these are the very close options, 4 alpha square P by 1 minus alpha. So 4 alpha square p by 1 minus alpha square. First one is 1 minus alpha square. So 4 alpha square p square by 1 minus alpha square. 4 alpha square p square by 1 minus alpha. First option is 4 alpha square p by 1 minus alpha square. Second option 4 alpha square p square by 1 minus alpha square. So we have to derive the relation between Kp for this reaction. So for this solution, you can see here carefully. Let's take the solution. So consider the reaction A gives rise to 2B. So initially this is 1 mole and this is 0. At equilibrium, we can say it starts dissociating. So at equilibrium, we can say this is 1 minus alpha, this becomes 2 alpha. So total number of moles is equal to, why we are finding total number of moles? Because we need to find mole fraction also. So total number of moles is equal to 1 minus 2 alpha, 1 minus alpha plus 2 alpha. It is equal to 1 plus alpha. It is equal to how much? 1 plus alpha. So now we know the total number of moles. So by this we can say Kp is equal to, for this reaction, Kp is equal to partial pressure. So first we need to find partial pressure of A and partial pressure of B. Afterwards we go for Kp, because, so anyway I'm writing here, since Kp is equal for this reaction, partial pressure of B square by partial pressure of A. Now question is how to find partial pressure of B and partial pressure of, let us see partial pressure of A. So I'm writing partial pressure of A, P naught. So P naught A is equal to total pressure into mole fraction of A. Total pressure into mole fraction of A. That is equal to how much it is? P naught. So total pressure is equal to P into mole fraction of A is nothing but what is 1 minus alpha by 1 plus alpha. P into 1 minus alpha by 1 plus alpha. This is what? Partial pressure of A. Next continuation here in the other page we are doing. Similarly, we can take partial pressure of B. Partial pressure of B is equal to total pressure into mole fraction of B. Mole fraction of B. I'm writing each and every step by step, so please note it down. Mole fraction of B. So that is equal to total pressure P into mole fraction of B. B is how much? Number of moles of B is equal to, number of moles of B is 2 alpha by 1 plus alpha. Total number is 1 plus alpha. That is equal to 2 alpha by 1 plus alpha whole square. This is also P square, because total it is whole square. Sorry, no need to take whole square here itself. So simply I'll write only partial pressure of B. Now substituting the values. Kp is equal to, for this reaction, what is Kp? Kp is equal to partial pressure of B square by partial pressure of A. So that we can take it as P square into 2 alpha by 1 plus alpha whole square divided by 1 minus alpha by 1 plus alpha, because partial pressure of A is equal to 1 minus alpha. So this is clear. 4 alpha square P square by 1 plus alpha into 1 minus alpha, because 1 plus alpha, so I'll write it here, make it more clear. So please note it down. This we can take it as 4 alpha square numerator P square by 1 plus alpha whole square divided by 1 minus alpha by 1 plus alpha. So 1 plus alpha, 1 plus alpha, one time it is going. So this 1 minus alpha will come to the numerator. So this becomes 4 alpha square P square by 1 minus 1 plus alpha into, because this 1 plus alpha will come denominator, into 1 minus alpha. Since 1 plus alpha into 1 minus alpha is equal to 1 minus alpha square, so we can say 4 alpha square P square. And here also P will be there, so P and P gets cancelled, so 1 P will get cancelled. So 4 alpha square P, 4 alpha square P, we forgot to write P here, total pressure into 1 minus alpha, 1 plus alpha. So 4 alpha square P divided by 1 minus alpha square, 1 minus alpha square. So answer is what? This is the answer for Kp, 4 alpha square P by 1 minus alpha square. You can see here now which option. 4 alpha square P by 1 minus alpha square, it is first option. So answer is first option. Answer is what? First option. So like these questions are most important. So you can see here, this is question number 8. Now next question, question number 9. So this type of questions are lengthy, but it's most important. Next we have question number 9. Further reaction. Further reaction, comma, SO2 plus half O2 gives rise to sulfur trioxide. SO2 is gas, half O2 is gas, sulfur trioxide is also gas. If Kp is equal to Kc RT whole to the power of X, where the symbols have this JE mains question, where the symbols have usual meaning, comma, then the value of X is option, first option it is 1, second option it is -1, third option it is -1 by 2, and fourth option it is +1 by 2. It's very simple. So if you take delta n value, so delta n is equal to, solution for this I'm doing it here itself, delta n is equal to Np minus Nr, that is number of moles of gaseous products minus number of moles of gaseous reactant, number of moles of gaseous products minus number of moles of gaseous reactants. So this delta n we have seen already in thermodynamics also. So number of moles of gaseous products minus number of moles of gaseous reactants, that is equal to, products is how much? 1 minus 1 plus half. So it is 1 minus 1.5, it is equal to -half. So answer is third option. Direct question, simple it is. So answer is third option. Like these questions you are expecting. Next, question number 10. Model number 10 we are going to discuss now. So these models are very important. That's why I'm discussing. H2 plus I2. H2 gas plus I2 gas gives rise to 2HA gas. In this reaction, Kp is equal to, in this reaction, comma, option 1, Kp is not equal to Kc. Option 2, Kp is equal to Kc, that is option B, Kp is equal to Kc. Option C, Kp is greater than Kc. And option D, Kp is less than Kc. These are the 4 options we have. So for this also simply we can find delta n. So delta n is equal to, so this type of questions we are getting more. Delta n is equal to 2 minus 2 equal to 0. So therefore, if delta n is equal to 0, Kp is equal to Kc RT whole to the power 0. So anything power 0 is 1. So Kp is equal to Kc. So answer is second option. That is B. Next, question number 11. Question number 11. A catalyst. Question number 11 is not required. Next question. Calcium carbonate on heating strongly forms calcium oxide plus carbon dioxide gas. This is solid. This is solid. The reaction in a lime kiln goes to completion because the reaction is carried out. The reaction is carried out in a lime kiln. In a lime kiln. Lime kiln is mortar. So you know how to mix cement and all for construction purpose. Goes to completion because completion because so lime kiln is an open surface. So option A, it is heterogeneous reaction. It is heterogeneous reaction. Option B, backward reaction is very slow. Backward reaction is very slow. Option C, carbon dioxide gas escapes formed escapes out. Option D, Kp or Kc has no unit. Kc or Kp has no unit. So answer for this question is, since lime kiln is an open surface, we can say it is open. So if you do it in open vessel, it is lime kiln is an open vessel. So that's why carbon dioxide gas so formed is escapes out. So that's why the reaction, actually if the reaction is at equilibrium, the reaction never completes. If the reaction is at equilibrium, the reaction never completes. Since the reaction is not at equilibrium because it is done in lime kiln, we can say, even though they are given like this, but we can say carbon dioxide gas formed escapes out. So that's why the reaction is carried out in a lime kiln goes to completion because carbon dioxide gas formed escapes out. That's why this reaction we should not do in open vessel. Since lime kiln is a open vessel, so it is not possible to get back calcium carbonate again. That's why the reaction is completed. If the reaction is at equilibrium, the reaction never completes. If the reaction is at equilibrium, the reaction never completes. And to keep the reaction at equilibrium, we have to do the above reaction, this reaction in closed vessel, not in open vessel like lime kiln. If this reaction is done in closed vessel, so the reaction will never complete. But as we are doing it in lime kiln is an open vessel. So that's why carbon dioxide gas formed escapes out. So the reaction takes place, goes to completion. Next question number 12. So all the different models, either theory or numerical we are doing. So far we have done numericals. That's why I'm doing theory questions also, because usually students will leave theory questions as they thought it is easy, but they are not easy because we have to remember the concept. So this question, a catalyst, first option, alters the equilibrium constant, alters the equilibrium constant. It's first option. Alters means changes. Second option, increases the equilibrium concentration of products, increases the equilibrium concentration of products. Option C, helps the helps in establishing helps in establishing the equilibrium the equilibrium quickly. And fourth option, supplies energy to the reactants. Supplies energy to the reactants. So answer is, so you already know a catalyst has no effect on equilibrium. It cannot change the equilibrium constant value. Only it can helps in establishing the equilibrium quickly. So that's why answer is third option. Suppose if they are given the statement like this also, has no effect on equilibrium constant, has no effect on equilibrium constant, that is Kc. This is also correct. So these two statements are correct. So a catalyst has no effect on equilibrium constant, only it helps in establishing the equilibrium quickly. So it helps in establishing the equilibrium quickly. So this is the answer. So question number 12 is finished. Next question number 13. These are all theoretical questions. So theoretical questions also we should not neglect because they can ask for NEET also. So that's why I'm not leaving theoretical questions also. Next question. Last question for this session I'm discussing now. So same model we have done. So all our different models we have done. Last important model, very important model. This model we have not done for this session. PCl5 dissociates as follows. Dissociates as follows. That is PCl5 changes to PCl3 plus Cl2. This already we know, PCl3 and Cl2 all are gases. This is the question. But for this, if total pressure at equilibrium, if total pressure is equal to P, if total pressure at equilibrium, which here is P, total pressure is P, comma, and degree of dissociation is X, degree of dissociation of PCl5 is X, comma, the partial pressure of PCl3 will be partial pressure of PCl3 here, and they are not asking Kp value, simply they are asking partial pressure of PCl3 is. So straight away you can say, so option A, X by X minus 1 into P. Second option, X by 1 minus X into P. Third option, X by X plus 1 into P. And fourth option, 2X by 1 minus X into P. So simply straight away you can find first, you can see the solution now. So they are asking not Kp value, they are asking only partial pressure of PCl3. So after finding partial pressure of PCl3, Cl2 and PCl5, we have to find Kp in general. But here they are asking only up to PCl3 only. So straight away we can say here for this question, PCl5 gives rise to PCl3 plus Cl2. Initial phosphorus pentachloride is 1, it is 0, it is 0. And at equilibrium, PCl5 dissociates to form 1 minus X because degree of dissociation of PCl5 is X. So it is equal to 1 minus X is equal to X and X. So total number of moles is equal to, therefore, after finding immediately, we have to find total number of moles because we need to find mole fraction. So total number of moles is equal to 1 minus X plus X. So it is equal to 1. 1 minus X plus X. So minus X plus X. and plus x, one more x. So it is equal to 1 minus x. So it is equal to minus x plus x gets cancelled. So it is equal to 1 plus x. So total number of moles is equal to 1 plus x. Now partial pressure of PCl3 is equal to partial pressure of PCl3 is equal to, that is total number of total pressure into mole fraction of PCl3. Mole fraction. So it is equal to P into mole fraction. Number of moles of PCl3 is x by total number of moles is 1 plus x. So P into x by 1 plus x. This is the answer. So P into x by 1 plus x is third option. So like these questions are most important. Please note it down. So either they can ask for Kp for the same problem. So for that you need to find partial pressure of PCl3, partial pressure of Cl2, and as well as partial pressure of PCl5. And Kp is equal to partial pressure of PCl3 by partial pressure of Cl2 into partial pressure of Cl2 divided by partial pressure of PCl5 for this reaction. So Kp they have not asked, they asked only up to partial pressure of PCl3. So they have cut down the question to half. So that's why we can do like this. So these are the important questions we have done from Kp and Kc. Next, we are going to discuss the relation between delta G, that is free energy, and Kc. So in the next topic, so we are going to discuss this delta G and Kp and Kc. So I hope it is clear. So next, we are going to discuss that topic. So with this, I'm ending this session. Thank you all.